Welcome everyone, this is AutoSolve, and in this series we carry on with learning Python programming from scratch. So the main punchline of this video is trying to go away from theory and exploring the concepts in a lot of detail, in the theoretical detail. We're going to try and dive straight into practice really and learn things as we go along. We're going to try and tackle some challenges, some common projects or mini projects that you can come and see in finance or accounting departments or taxation teams. So, to kind of kick this off, the task we're going to be undertaking today is to do with comparing actuals with budgets. So, a common situation in finance, tax, or accounting that we have is kind of the senior management creates the budget. And we kind of look at actuals and compare the two and trying to find the differences, trying to find the variances, and trying to see how well we're doing along various aspects of performance, financial performance. So we're going to use Python to kind of automate it and streamline it, right? Because normally these kinds of things are done in Excel or databases, right? You can write queries for these things, but anyways, we're going to try and use Python, and we're going to try and automate it as much as we can, so hopefully you get to enjoy it. So to kick this off, we have a Google Colab set up right here. So we're going to try and connect it to the runtime, and we're going to use the very easy CPU cheap sort of runtime. And we're going to connect it to kick this off, because that's what we need to run the Python on the virtual environment on cloud. So now we need two files. So I've prepped the two files for our example today. Feel free to use yours. So here I'm going to open the files tab, and I'm going to deposit two simple files into the workflow. Just wait a second. Wait a second. Oop. Where are the files? Right, so we have the budget file that's being deposited, and we have the actuals file. Just drag and drop into the tab here. So let's see. So we've got the budget, the actuals still haven't updated for some reason. Right, there we go, we got it. So awesome. So let's look at actuals. So here within Google Colab, we can kind of look at the files, and we can see that this file, actuals, contains the column for month, which contains the year and a month. Then the following column is category, which contains some text sort of inputs. And we have actuals, which is numeric, right? So we've got budgets as well. We're going to open this up, and you can see straight away from here that it's kind of similar in the format. Pretty straightforward. Month again with the date, and we have category again with the budget. So ideally what we want to have month, category, and we want to put budget next to actuals in the same row, so then we can compare them, right? So what do we do now? We can close these down. Let's open our first cell and kick this off. So in order to kick this off, we need to have a special import module called Pandas. So we're importing Pandas because that will allow us to work with data, with tables, and perform our manipulations. So as the next thing, we're going to try and perform the imports of the files. In order to do that, we just use PD because we've imported Pandas as such, PD. And we're going to say read underscore CSV, and we're going to put the name of the file. So we have actuals first, .csv, and obviously we're importing it, we're bringing it in, but we need to save it in a special container, the variable. So let's call it actuals. We obviously can pick whatever names we want for the variables, and we do the same for the budget. So we're going to say budget variable will contain pd.read CSV, the budget. So we have two variables, and we can start working on them. So just to kind of make sure that we've imported our stuff, let's do a little test. Budget.head will show us a couple of first lines, and we're going to do the same thing for our actuals. Actuals.head. Right, yeah, we got it. So it seems to be working. We've just made sure that we've got our data inputted now. So what can we do now? So for first, let's try and perform some data cleansing, right? So let's type it as data cleansing. So the issue that sometimes we have is sometimes from various files, because files come out of various systems, you know, that produce the actual output. Sometimes they might have extra characters, extra trailing or leading spaces, tabs, and etc. So we want to strip them of these. So we want to have them as generic as possible, because we need to perform a comparison when we're merging two data sets, when we joining them together. The Pandas, Python, or if we're using SQL, or if we're using Excel, unfortunately, if the same string on the two sides of the data sets in the budget and the actuals, if I don't know, the category of travel, for instance, has a leading or trailing space, right, and the other one doesn't, it would not bring them together. This would prevent them from being joined together, right? Because the PC might look at two strings and say, right, so this string has only travel without any spaces, but the other one has travel with space, and that's not the same thing. To us, it might look like they're the same, they should be joined together, right? But the PC doesn't see it that way, and the Python doesn't see it that way, so we have to do some data cleansing. So in order to do that, we're going to create a cell, and let's create the loop. So the loop will say for data frame in. Now here we're going to use a new type of data that I don't believe we've used before. It's going to be a tuple. So tuple is just a fixed list of things that you cannot play around with or change anything in. So we're putting budgets and actuals. So we're putting our two data sets here, budget and actuals, into this tuple. And this tuple, well, we just iterate over it. So for everything that's in the list, which is the two items, budget and actuals, for every item in this tuple, we're gonna take it down as data frame df, which is a temporary variable that will be available within this loop, and we're going to do something with it, right? So it's going to say df data frame. We're going to say month. So we have this column here called month, and we're going to do some changes with it. So month column, we want to do some changes. Let's strip it off everything and ensure that it's down as string. So month, we're going to say as type. That will allow us to cast it into the string, and we're going to say string.string strip. So that will ensure that all the spaces are gone, leading or trailing. Next, category. We do the same thing with category because they're both strings, so we want to be careful. And plus, these are the fields that we're using for joining anyways. We have to perform this data cleansing just in case. Might not apply to our particular file, but whenever you come around to doing the joining, it's really important you do this easy yet very important step. Because if you're performing a massive analysis with plenty of data rows, the last thing you want to do is to just start seeing that something's not matching up, spend a lot of time finding out why it's not matching up, and then finding out in the end that you've not performed these data cleansing steps. So we've effectively done the same thing here. So we are kind of making sure that these columns get cleansed. And as a next step, let's try and ensure that we don't have any empty numeric values for actuals and for budgets. Right, so we start with the budget. Now we're going to process the numeric ones. Go budget, and the column was called budget. It contains the amount. So we say Pandas PD2 numeric. Say budget errors coerce. Right, so we're forcing errors. So we're kind of ensuring that we're forcing the budgets to be converted into numeric, right? Because sometimes it could be coming through as a string. But yeah, so the Pandas has a native function to avoid that. And everything that gets turned as not available, we are converting it to 0 with a floating point. And the same gets done for the actuals. PD to numeric, actual errors, yeah, just auto completed this for us. Yeah, so once again, so what we're doing here, we're going into these individual amount columns, and we are kind of saying, okay, whatever this is, just make sure it's numeric, and if there's any errors, leave them as blank, and obviously everything that's blank, we're just filling it out as zeros, yeah, in case there's any transition errors or conversion errors that the third-party software happen to have made. And to be honest with you, there's no need to test it here, but we can have a look again. Let's run it first. I don't think we're going to see any changes to our data set, right? So if I'm going to say budget head, we are not seeing anything different. It's all still looking relatively same. No, I don't think there's any changes. And if we do actuals, once again, I'm not seeing anything different, but we've ensured that it's going to stay in the comparable format, because the next step will be joining the stuff together. All right, so let me just put a comment here. Joining on month and category. All right, so let's do this. So in order to perform this, we need to create, we'll create a variable now. So it's merged. This will be our variable. This is the variable that will combine the two data sets. Right? So once again, we're going back to our pandas, our imported pandas library, and we're using this function called merge. So we are merging the budget and actuals. Yes, so it's correctly auto-completing here. So now we open the braces, and we're saying, okay, budget, actuals, and then the next parameter will be on. So it kind of details what fields we're actually using. So we're specifying on equals. This is where we do the specification. We say month. We're going to use the column called month. And this is where it's beneficial for us to have the same naming convention for the two data sets. And category. Month and category is the way to go for us. And the next one is how. So how do we perform the joining? So whenever we perform, I don't know if you've done this like with SQL, with databases, with SQL queries. Whenever we have two data sets, right, we could be interested in matches between the two data sets, just the matches. So some of them could be falling out of the equation, falling out of this reconciliation. For instance, in our case, because we're joining on month and category, maybe there might be category available in the budget or actuals that's not present in another one. So maybe we might be having here, we're looking at actuals. Maybe we would have actuals for miscellaneous, right, which is not available in the budget, right? So that category particularly would fall out of this reconciliation. And if we're not interested in everything that falls out of the reconciliation, we tend to use the inner join, right? So there's inner join and then there's outer join. Outer join pulls everything together, right? And it kind of produces the comprehensive summary for you. And inner one only looks at things that are present in both data sets, in actuals and the budget. So we're going to use the outer one, right? So here we've got that, and once again, because we're using the outer one, that might leave some null values, and we're going to fill them out. Right, we're kind of saying, okay, perform this merging, perform in this joining, but whatever you have as zeros, as empties, just fill them as zeros with a floating point. Okay, so let's run it. Oh, we've got a little error. Let's see what we've got. Alright, so data frame object has no attribute fill. Oh, this should be fill in A. Uh-oh. Once again. Let me try again. Yes. So now that successfully runs. So let's have a look at what we have, right? Let's try and see if that makes sense. So merged dot head. Let's have a look at what's happening there. Yes, so we have our month, our category, and we have our budget and actuals right next to each other. Now, in our particular case, we are not seeing any 0 or NA values, no available values, right? So we're fine for now. But if we had them, they should have been converted to zeros. Okay, so we are prepared to start building our summary or analytics piece. Now we've performed the merging, the joining now. So as a next step, let's have a look at variance, right? So let's create a column that will be titled as variance. So merged. To create a new column, we just have to specify it like this. So variance. And you can name it whatever you want. And we're going to say it's going to equal. So the formula here will be actual minus budget. Right? So we're kind of saying, so the new column variance will be a combination of actual, take away, budget. Let's run it. And let's view our dataset, merge dataset again. I'm going to do it in this above cell. Right, so we have here budget, actual, and a calculation of variance. Brilliant. But that is a absolute variance. We probably want to try and create a percentage one, right? Because it's nice to have it. It's nice to be able to tell our stakeholders and senior managers that this is how much we were out, or how much we were by how much we were exceeding our expectations, our budget. But stakeholders love to see it in percentage. So let's try and provide this. So merged variance, And let's put it down as PCT, which stands for percentage, and we say merged dot apply. Merge dot apply. 1 second. Right, so let's see. Merged variance actual budget. So here we're gonna try and apply a specific expression, right? So I'm just gonna type it out. It's gonna be easier for me just to type it out. So we are passing a row, right? And we're passing a row to our formula, every row in fact. And for every row that we're passing, we're going to build this temporary sort of expression that will use this row as a variable r. We're specifying it here and we're using it here. So the row, and we're specifying we would like to use only variance piece of that. Variance piece of that. Yes, this here is a new type of Python construct that we've never used before. Let's just think of it as a flexible expression that we're passing. That we can construct and detail and customize. So we're saying, okay, so the row object variance divided by the budget, right? Because variance over the budget will give us how much the variance is in terms of the percentage. Now, variance over budget will give us a fraction, so this will be 0 point something, hopefully, right? Hopefully variance is not too large. So this will be 0 point something, which is a fraction, right? So we would like to obviously elevate it to the whole percentage. And we do it by multiplying by 100. And if, so that will be executed if the R, so that's the row, and if the budget does not equal, so that's exclamation mark 0, and if that's not the case, if it equals to 0, we just put down as 0%, right? Because if the budget is 0%, then there's nothing for us to do here. What's the point? Right, so the very important piece here is that we are doing it, over axis equals 1. So axis equals 1 would effectively mean that we are doing this over the rows, right? Because we're passing the variable r, and in order to do that, that needs to be axis 1. If we were to put axis 0, axis 0 would effectively mean the column, so we would be passing a column, which would not work in our case because we want to, we're creating a column, so we need every row. And as we need every row, once again, we use axis. So let's see if this actually works. Let's look at our expression. I'm coming back to my cell here prior to that one. So yes, let me just pull up a calculator real quickly. 1 second. Just to test it, right? We must always test. Calculator. Right, calculator. So we are going to say something like, let's test that one. So the budget, so 17.8, 17.9 over 200. The budget was 200, so we're doing this over that one. 200 and so we are getting 8.95%. That's fine. That's exactly what we want. Right. So yeah, so that worked. That seems to have worked. So we can tell now that, for instance, for fuel, we are not doing so well with the budget. In fact, you know what? I think no, this is a really good metric here. So our budget was 200. We've gone under budget. So a minus variance here would be positive because we're spending less, right? So for meals and entertainment, minus 20%. Then office supplies minus 13. Taxes minus 16. So yeah, it depends on how you look at it. Suppose we can actually adjust this formula accordingly. So if these were the sales, right? How much sales we were doing, right? Let's say we probably would have wanted to change the sign, right, within our formula, and we can do it very easily because we've just built this expression here, right? So depending on what you want to do, you can kind of adjust this formula here and just put a minus sign in front. Okay, moving on next. So what have we got now? So we have got our report. Let's produce the report and save it. So how do we do it? We take our lovely data set merged and we do to CSV. And we're going to do a column here as summary variance underscore summary variance dot CSV. Let's save it. Let's refresh our panel here, and we've got our report. There it is. Look at that. Brilliant. Okay, so we've saved our file. Now let's try and build another type of summary with what we have. So let's call it different summary. So far we have months, category, budget, actuals, variance. But what if we wanted to, I don't know, kind of aggregate it a little bit more? So let's perform some aggregation functions. So we say we create a new container, summary, and we say, okay, so this will be our expression. We're going to take our merged and we're going to group it by two variables. So we're going to say, okay, group it by, in fact, let's put it in the list, right? Because we have to put it in the list. So let's say do it with a month, and let's aggregate it and group it by category as well. Right, and let's do as index equals false. That's just to make it work. And right, yeah, so that would run, but we would like to, in fact, let me just find this. Yeah, it would run, and let's see what we actually would have. But this is still a little bit incomplete. So summary head equals, right, so yeah, so it's still incomplete. So we would like to aggregate it further. Aggregate it further by further. We would like to aggregate it further by budget equals sum. Right, so here we're kind of specifying what we want to do. So we have the column called budget, and we would like to call it as a sum. But that's not the only one that we want to perform aggregation on. We want to also do the actuals. So to do that, in fact, you know what, let me just change the shape of this a little bit because it's becoming a little bit confusing now. So we've got that one, the actuals. So we'll have a column for actuals, and we're going to use the column of actuals as a sum as well. Right, so yeah, that should be fine. And obviously we need to do something with the variance because we also have the variance sticking out as well. So let's do variance equals variance and sum, and that percentage, we don't actually need it. Right, so that is done now, but it doesn't like something. Yeah, let's change the actual budget versus actual. Right, okay, so we've got this now. Budget, actual, variance. One second. Right, there we go. Right, so yeah, that's our new data set. So what we did here, we took our merged data set, we performed grouping by month and category, and as we were grouping it for month and category, we said, okay, these are the fields we want to carry forward and perform aggregation upon. And that is how it looks now. So kind of we're done with that. Let's just do a final piece of sorting. So we're going to say, take summary, take what we have of summary as of now, and say let's sort the values. And this is how brilliant Python actually is. It's got such intuitive touch to it, with all the naming conventions for all the functions, and so it's been done really well with analysts in mind. And for key, we're going to once again use lambda. So we're going to pass the expression, and we're going to say s for s absolute. It's a function. So effectively, we're passing a number. Right. So ascending dot false. And let's see how it actually looks now. Right, type in this out, there we go. Yes, so as you can see, before our variances were all over the place, but now we're just kind of saying, okay, so whatever the variance is, because we're sorting it by variance, whatever the variance is. Now we would like to, we don't care if it's minus, if it's plus, if it's positive, if it's negative. We just want to see the largest ones first, yeah, because we don't want to do it in descending order. We want to do it in descending order, not ascending. So that is it. Now this is another report that we built today. Let's try and save it. This should not be a problem after everything we've done. Just say summary dot to CSV and summary variance absolute.csv. That report has been saved, and we are able to see the results in this window. So I hope this was useful. What we've learned now, we were able to perform or use Python in order to automate joining of two data sets, actuals and budgets. We were able to combine them, perform calculations, work out percentages of variances, aggregate them, perform aggregations to kind of consolidate the reporting a little bit. If we have too many lines, we would have had less lines now. And we were able, yeah, so we've effectively performed some analysis now. This would be extremely useful for senior stakeholders. This will be quite insightful, and we've just had a basic type of report. There's many of dimensions we could have used, selected for aggregations, for groupings, and for further analysis. I hope you enjoyed this video. We're going to carry on with another project in the next one. Please let me know if you think there are better automations, challenges that you think we should tackle. I would be delighted to hear them and potentially attend to them. Thank you so much.